Today we'll start about in the last class we seen the introduction to the Verilog. Okay. Today we'll start about what is this data types present in the Verilog. Okay. Yesterday we started the Verilog. Okay. Data types in Verilog. So data types. What is data type? Data type is nothing but like suppose one variable is there. Okay. So one variable is there. How you are defining that variable? That is nothing but data type. You are how you are storing that. Variable in the in where how we are storing this variable in the I think my screen is visible. Okay, so how we are storing that variable in the CPU. Okay, is nothing but data type. Okay, data type. Okay, yes, yes. Okay, so data types in Verilog. Data types in Verilog. Okay, we see the data types in Verilog. Basically, you have first net data type. Okay, net data type. So what is this net data type? Net data type is nothing but in net data type you have wire data type, var data type, okay, and next WAN data type. WAN data type. Okay, so these are the data types present in the Verilog. Okay, so here data type is nothing but what is data type, how we are storing the value. Okay, how we are means declaring a variable, how we are declaring a variable. So the like in C language you can declare like variable as char, int, float. Okay, like that you have data types in the Verilog. Okay, suppose if I call wire a is there. Okay, wire a. Okay, the wire a, so this is wire is nothing but what, this is a data type, this is data type, or this is a keyword. Last class I told you, know, so many keywords are there in the Verilog. So like that, that is a keyword, and this is identifier, we can call as identifier, or we can call as a variable name, a variable name. Okay, variable name. Okay, uh, so I will tell you some basic concepts. After completing the basic concepts, we will go to the programming part. Okay. So what is the default value for this default value of wire? Okay, default value for wire is what? Default value is wire is what? High impedance. High impedance. High impedance is nothing but yesterday we already seen the value set. What is the value set? Verilog will support four state data type. Okay, four state. Four state means what? It is 0, 1, X, Z. High impedance is nothing but by default it will be not connected. This is nothing but high impedance, not connected. Okay, so this is what this is the so wire data type. Okay, now so yes. So here if you see wire data type, suppose if I consider like a module. Okay, so for this Verilog I can use this Xilinx Vivado, or I can use what we call I will use EDA playground also. Okay, I can use EDA playground also. So this is open source software. I am using EDA playground. So I am opening. You need to create one account in the EDA playground. Okay, so with a Google you need to create the EDA playground. So I already created. So here I can use this. Okay, I can use this. So here you can write the design here, and you can write the test bench here. Okay, so you can write the program. Suppose with respect to data types I am writing the program. I think it's visible, no? Yes, I shared the screen. Okay, it's visible. So here if you write the program with respect to this data types module, let us take some example. Okay, module, you can write test also, module test. Okay, I am using assign a equal to what, some 0. Okay, a equal to 0. Okay, a equal to 0, and assign a equal to 1. Okay, a equal to 1, and I'm initializing this data type. So here I'm writing the design only, I'm not writing test bench. Here I'm showing the design only. Okay, so here tools and simulators, in the tools and simulators you need to create Aldec Rivera, and languages you can write in system Verilog or Verilog. Okay, so by using EDA playground you can write the program in system Verilog or Verilog. Okay, so here what I am doing, one second, somebody is okay, yeah, okay. So I initialized this wire a, okay, wire a. So there is I want to display this value. Okay, so I want to display this value. So for displaying I'm using dollar display. Dollar display is the system task. Okay, dollar display the value of, okay, one second. Dollar display the value of a is suppose I'm giving the, if it is a format specifier, I'm using percentage d comma a. Okay, screen not visible. One second. Now is it visible? Your response. Now is it visible? Anyone? Yes. Okay. So see here. So first module test where a assign is nothing but continuous assignment. Assign a equal to 0, assign a equal to 1. Dollar display the value of a is percentage d comma a, and I'm writing this so end module. Okay, end module. So end module. Okay, so end module. So here I want to save this program. Okay, I want to save this program, and next if I want to run. Okay, so that means what may be this output, can anyone guess what may be the output of this code? What may be the output of this code? Here first I am assigning a equal to what, 0, and wire a is nothing but what, 1 bit value. Wire a equal to 0 and assign a equal to 1. So that means so the default value is z. First I mean, so wire is nothing but one data type. It will not store any value, just we can drive the value. That means we can drive some value, into that wire data type. So basically if I run this program, so it will show that the value of a is x. The value of a is what, the value of it will show the value of a is somewhere. Again, 1 second, we will see. Design 11, 11, where is 11? 6 dollar display the value of a is if I take not d, percentage b, if I take save run, compile, one error, 1 second, unexpected, assigning a display value of e, output a equal to x you need to get. Okay, assign means here wire a I need to write initial. Okay, initial, and next begin, not initial, begin and end. You need to write, if it is multiple statements, you should write between the begin and end. Okay, begin and end. Okay, multiple statements are there, you need to write in terms of begin and end. So here when I run this code, I'll get the value of a is x you are getting. Okay, the value of a is you are getting x. Okay, so that means you are getting like unknown value. Okay, you are getting unknown value. Okay, the value of x is unknown value. Okay, so suppose if you want uh, the value should be either a 0 or 1, so this Verilog, if you take the Verilog is a sequential, means concurrent language. Concurrent language is nothing but what, it will execute parallelly. It will execute parallelly. Okay, concurrent. Verilog is a concurrent language. Okay, whereas high level language C++ are there, no? So those are sequential languages. Sequential languages are nothing but what, serial languages. Okay, serial languages. Okay, so this one I can show you in the Xilinx Vivad also. So this one, if I see, if I open this Xilinx Vivado, one second. I'm opening the Xilinx Vivado. So this is Xilinx Vivado. So I will tell you how to create the project and all those. So I'm opening the project. One second. I'm opening the project. Here now I'm in which folder? This folder, no? Okay. One second. Okay. Verilog programs. Data types. See here, data types. I'm opening with the Xilinx Vivado. It's not opening. Yeah, it's opening. One second. It will open the project. Here it's open. Okay, I will show you. See here, test1 is there. Test1 program is there. So this test1 program, I'm just initializing reg. Okay, test3. Okay, so that is this thing, if you are giving a wire data type, so if you are giving two values, it will take don't care condition, unknown value. Okay, unknown value it will take. Okay, and next, suppose if you so two values are using, and next you have var data type. What is this var data type? Suppose module example. I am using var m. Okay, var m, assign m equal to 0, assign m equal to 1. Okay, and so what it will do? So basically what it will do, so var means what, it will do the OR operation. OR operation means what? So that means 0 OR of 1. So that means the output you are getting 1. Okay, that is nothing but one second. Okay, so this is about the var operation. And next, WAND also there. What is this WAND? So WAND means so WAND is suppose if I use WAND and so assign, if I give assign w equal to 0, assign w equal to 1. Okay, or we can use WAND a equal to 0, WAND some b equal to 1. It will do AND operation. 0 AND of 1 means what you are getting AND. Okay, so this is about this is about the wire data type. Wire data type will not store any value, just we will we will drive the value. Okay, it will drive the value. Okay, suppose what is the size of this? Suppose if I consider wire A. Okay, what is the size? This is 1 bit only. The size is 1 bit only, wire data type. Okay, wire A. Okay, width is 1 bit. Okay, and suppose if I consider A equal to 0. Okay, A equal to 0, so that means wire here an initialized wire A, no, so this is 1 bit, but here this is 32 bit, this is 32 bit. Okay, similarly, so here if I am giving A equal to 1, this is 1 bit, and this is 32 bit. Internally in the compiler, how it will store means 0 0 0 up to so on 31 zeros, next you will get 1. Okay, so like this 32 bits it will store. Okay, so this is about the wire data type. And next reg data type. What is this reg data type? By using reg data type, we can store the value. We can store the value. Okay, so we can store the value by using reg data type. We can store the value. Okay, we'll store the value, or we can store the data. Okay, or data. We can store the data by using reg data type. Okay, suppose like let us take example module example regex initial A equal to 0. Okay, end module. Okay, here what I am doing, here I initialized what reg A. Here if you consider reg A. Okay, so reg A means what? Reg A, I initialize reg A, so I'm storing the value, storing the data, that is 0 to A. Okay, so what is the default value? Default value for reg data type is default value is x, unknown. Okay, default value is unknown. Okay, suppose if I consider like reg A is this is 1 bit size. Okay, 1 bit size, and this wire data type and reg data type are unsigned data types. Unsigned data types means what? Suppose if I want to store some value, suppose negative value is there. Suppose if I want to store negative value -6. Okay, so in the compiler it will store in terms of what? 2's complement only. How we are representing negative numbers in the digital, I told you. So we are representing, that means 1 1 0, and this is sign magnitude, this is 1, no. So how we are applying 2's complement? 1, so this is the 1's complement 0 0 1, adding 1 to this is 1 0 0 1. Okay, so basically in binary it will display like this. Okay, but suppose if I want to display in terms of decimal, it will display 9 positive values, it will display. So that's why wire data type and reg data types are unsigned data types. Okay, unsigned data types. Okay, so this is about wire data type and reg data type. Is it fine now about the wire data type and reg data type? Shall I move forward? Any doubts in this? Yeah, give response. Yes or no. Okay. Next you see, next vectors. What are these vectors? Okay, vectors is nothing but grouping the multiple bits into single. Grouping the multiple bits into single. Okay, that is vector. So what is the syntax for vector? Syntax for vector is data type range variables. Okay, so what are the data types I can use? I can use a reg data type, I can use wire data type. I can use reg data type. Only these two data types you need to use in the vectors. Okay, only these two data types I need to use in the vectors. And next, what is the range? There are two types of ranges are there. Okay, one is MSB down to 0, MSB down to LSB. Okay, MSB, this is what down, we call as down, MSB down to LSB. and next is LSB to MSB. Okay, so like there are two types of processors are there, like little Indian and big Indian. So basically MSB down to LSB means big Indian, and LSP to this is 2 LSP to MSB is nothing but little Indian. Okay, LSB will store first. Okay, LSB will represent first, and after that MSB. Here MSB will represent first, and after that LSB. So basically in the Verilog we will follow this one, MSB down to 0. Suppose if it is like 8 bits are there, 8 bits are there, how we are representing 7 down to 0. Okay, if there are 16 bits are there, how we are representing 15 down to 0. 4 bits are there, how we are representing 3 down to 0. 3 down to 0. Okay, so like this is nothing but vectors. So within the variable, if I want to represent this only multiple bits, we will use the vectors concept. Okay, suppose if I want to store some 3 tick binary. Okay, 0 1 1. Okay, if I want to store 3 tick binary 0 1 1. Okay, yeah, 0 1 1. Okay, before that I missed the basic constructs. Okay, after completing I will tell you the basic constructs. 3 tick binary 0 1 1. Okay, so this is what module example. So how I can store this value, module example. How many bits? This is 3 bits. No, this is 3 bits. Okay, so here reg 2 down to 0 a, 2 down to 0 a, initial a equal to what, 3 tick binary 0 1 1. Okay, end module. Like this I can use. Okay, so vector means what? That suppose 0 1 1 is there. This is 0 index, first index and second index. These are the index values, indexes. Okay, we call as indexes. Okay, so like this there is a vector. Okay, suppose if I want to represent if I want to store this 4 tick binary 0 1 1 is there. Okay, so how I can represent reg 3 down to 0 a, 3 down to 0 a. So that means whatever the size is there, size you will get before the variable. Okay, so that is so here if I want to use like reg 0 to 3 a, this we are not using. Okay, we are using 3 down to 0. Okay, that is the vectors concept. Okay, and suppose if I want to store some value like 7-bit value is there, 6-bit value is there, reg 5 down to 0 m is there, 5 down to 0 m. Okay, m equal to some value I'm storing 0 1 1 1 0 1. Okay, what are the indexes? 0 1 2 3 4 and 5. These are the indexes. Okay, there is a concept called vector slicing. Okay, what is this vector slicing? Suppose I can access any bits. Suppose if I want to access bit 2 and bit 3, I can access. Okay, and if I want to access bit 0 and bit 1, I can access. Okay, so how vector slicing will work? Module, let us take module TB, reg 5 down to 0. Let us consider this is m. Okay, reg 1 down to 0 n. Okay, initial m equal to 6 tick binary, this value 0 1 1 1 0 1. Okay, end module. So that means here n equal to what? N equal to I can access this only bits 0 1, n equal to 0 1. These 2 bits will be stored. Okay, these 2 bits will be stored. Suppose n equal to m of this I initialized. Okay, this I initialized reg 1 is to 0, I am using n is to equal to 3 is to 2. N equal to what? 3 is to 2. This is vector slicing. So that means the third bit and second bit index value I can access. So n equal to what? This is wrong. N equal to 1 1. N equal to what? 1 1. This is nothing but vector slicing. Okay, vector slicing. Okay, like this I can use. Okay. Yeah, 1 second. Yeah, okay. So vector slicing, this is about the vector slicing. So I told you, no, reg and wire is a non reg and wire are unsigned data type. Suppose if you consider like reg 2 is to 0, 2 is to 0, a is there. Okay, a equal to I am giving as 6. Inside a will be stored in terms of what? It will be stored in terms of binary, that is 110 it will store. Okay, so 110 it will store. Okay, suppose I am initializing reg 2 is to 0, a reg 2 down to 0, b. Okay, I am giving a equal to 6 and b equal to what? Minus 6. Okay, so internally what it will store? So if it is 6 means a becomes what? 110. Okay, if you write a data display the value of a is percentage b, like that if you write it will store in terms of binary. If it is minus 6, so if it is minus 6, how it will store means like plus 6 means what? Plus 6 means it will be stored in terms of what? 2's complement, unsigned data type means what is 1's complement? 0 0 1, adding 1 to this, it is 0 1 0. It will store in terms of 0 1 0. So that the value will be what? 2, not minus 6. If we want to display in terms of percentage d, the value it will display 2. Okay, so that means we can say that wire data type and reg data type, reg and wire data type. Okay, wire data type are unsigned data types, unsigned data types. Okay, these are unsigned data type. Okay, and next you have integer data type. Okay, so what is this integer data type? Integer data type means these are signed data type. Integer data type, these are we call as signed data type. Okay, if we want to store signed numbers, signed data type, if you want to store signed numbers, this is signed data type. Okay, so the width of this integer data type is 32 bit, width is 32 bit, signed number. Okay, and what is the default value? Default value is x. Default value is x. Okay, suppose if I consider integer a equal to 2. Okay, inside how it will store? Inside it will store in terms of 32 bit it will store. Okay, it will store like so like this it will store. So 1 0, remaining all are zeros. So this is 0 to 31. So inside the compiler it will store this is a of 31 and this is a of 0. Okay, this is packed data type. Packed data type means what? We can't do vector slicing. We can't do vector slicing in the integer data type. Okay, we cannot use vector slicing. Okay, vector slicing in the integer data type. Okay, suppose from this if I want to access integer 3 is to 0 a, this is not allowed. Okay, this is a packed data type. Okay, packed data type. Okay, suppose if I consider example of integer data type, so here suppose you can try this module tb integer m, okay, integer m, initial begin m equal to -2. Okay, dollar display the value of m is percentage d comma m and end module. end module. Okay, end module. So what is the value of a? So it will store in terms of what? Percentage d. Okay, percentage d means so it will store in terms of 2's complement. That means 0 1 0. What is 1's complement? 101. Adding 1 to this, it will store in terms of 110. Okay, this one we'll see in the EDA playground. Okay, I'll write this program in the EDA playground. Just you try this EDA playground. So here I'm writing the program. So with respect to integer data type, okay, so I'm writing the program module 1 second, okay, module tb, okay, module tb, integer I'm giving m, integer m, initial begin, okay, begin m equal to I'm giving -2, m equal to -2, okay, integer I initialize now, initial begin m equal to -2, I'm using system task $display the value of m is, first I want to display both both first decimal, okay, dollar decimal, and I can display in binary also, binary, okay, and comma m, okay, m comma m, end module, okay. This I am saving, running the program. Yeah, I got 2, no, see here I got -2, $display is -2, so that means here m equal to -2, I think you are observing this one, m equal to what? -2. So m equal to -2 means it will store, it's a signed data type, it will store in terms of -2. So the default size of this one is what? 32-bit means so -2 I given, that's why it will store in terms of 32-bit in 2's complement form, okay, in 2's complement form it will store, okay. So in 2's complement form it will store. Suppose here in this, in place of integer, what I am doing, I am using let us take reg data type, reg, okay. I am saving this, I am running this, what I got, see here the value of m is 0 I got, okay, but the value of m is percentage d, reg m initial begin, okay, okay. You can here you can give like integer or wire. If I take wire, if we are using wire, I need to use a continuous assignment, that is assign statement, okay. Assign m equal to what? M equal to -2. I'm saving this, I'm running this, okay. I think I got error, okay, initial begin, okay, there is some problem with the wire. So integer means you will get, okay, integer m means it will store in terms of 32-bit, okay. So you got this value, okay, integer m. Here if I want to give the size, so here if I want to display in terms of 3-tick binary, okay, 3-tick binary or 3-tick decimal, if I am giving 3-tick decimal 2, okay, 3-tick decimal or negative value is there, no. So if I want to see my positive value, save, run, what it will get, we'll see, okay. What I am getting, the value of m is what? M is equal to so 2, and I am getting 2 is nothing but in terms of positive, no. So positive means 32-bit here we are getting, okay. 3-tick binary, I need to give 1 second. Suppose if I give binary, 3-tick binary, save and run, I got some error, okay. So this is about suppose if I want to store some negative values, so -6 is there, so minus 6. So this will execute the negative numbers only. So that integer value is displayed in terms of integer value is displayed in terms of minus 6, and here are not specified any size, so that's why by default it is showing in terms of what 32 bit, and it is showing in terms of 2's complement. Okay, so this is about the basic data types. Okay, hope you understood. Next you have integer data type, and next you have float data type. Okay, so float data type, so if you take the float data type is easy to store the floating values or decimal values. Okay, float data type are used to store the fractional numbers. Used to store the fractional numbers. Okay, so what are the so means what is the size of this float data type? Size by default size is 64 bit. Okay, default value is x. Okay, and this is signed data type. Okay, and you have time data type also. Time data type is nothing but it will display the simulation time. And size is 64 bit, and time cannot be negative. No, this is unsigned data type. Okay, unsigned data type, and so this is used to track the simulation time, and the default value for time data type is x. Okay, this is unsigned data type. Okay, these are the data types. So here if you see, like I told you in the last class, that is synthesis and synthesis is nothing but what you are converting your program into hardware. No, program to hardware, that means your program to gate level netlist. Okay, so here what are synthesizable data types and non-synthesizable data constructs? We call as I'll write synthesizable constructs. Synthesizable constructs are nothing but what which are converting into hardware. Those are synthesizable constructs. Non-synthesizable constructs are nothing but which are not converting into hardware. Those are non-synthesizable constructs. Okay, non-synthesizable constructs. Okay, so what are synthesizable constructs? So wire data type, word data type, WAN data type, and reg, vector, integer. By using this we can convert into hardware. Okay, and these are nothing but synthesizable constructs. What are non-synthesizable constructs? Float data type is there, no? So by using float data type we can't convert into hardware. These are nothing but non-synthesizable construct. Time is also, I think time is also non-synthesizable. Okay, by time this time data type you can use in the test bench. Okay, simulation purpose we can use, but using time data type you can't convert into hardware. Okay, so this is about the data types. Today we discussed about this what is data type and how many types of data types are there. So basically there are like two types of data types are there: net data type and variable data type. So net data type you will get wire data type, var data type, and WAN data type. So wire, basically mostly we will use wire data type only. Wire data type you are using in continuous assignment, and basically in the behavioral modeling we are using output as a edge data type. Okay, so in data flow modeling basically we are using the wire data type. Suppose we already see in two values we are giving, the compiler will not understand whether the m value is assigned to 0 or 1. We are getting the output as x. So in that situation we need to use WAN data type and var data type. It will perform the OR and AND operation. Okay, and next read. So this will not store any value, just it will try the value. Okay, and reg data type we can store the value. Okay, we can store this value, that is reg data type. Okay, These two are unsigned data types. If you are giving negative value also, it will in the binary it will show in terms of 2's complement, but in the decimal it will show in terms of positive numbers only. Okay, vectors is nothing but if you want to group the multiple bits into single variable, we can use vectors. So basically we'll follow MSB down to 0. So if you want to store multiple bits, vector slicing is possible. That means if we indicate if you store 6 byte of information, if we want to access some 2 bits, 3 and 2, vector slicing is possible. Okay, and next integer data type, that is 32 bit size, and this is signed data type. If you want to store any negative value, we can use integer data type. Okay, and this is it will show in terms of a negative number. The default size is 32 bit, and vector slicing is not possible in the integer data type. And float data type, if you want to store some fractional values, we are using float data type. Okay, and size is the 64 bit, and default value is x, signed data type, and the time is to display the simulation time, we are using time data type. Default value is x, and this is 64 bit. There are synthesizable and non-synthesizable constructs. You have wide data type, var, vand, reg, vector, integer. These are synthesizable. By using this, we can convert into hardware, but float data type we can't convert into hardware. Okay. So these are about the data types. Tomorrow we'll see about this value sets. I will explain you. Okay.